Assalamualaikum and hello everyone. We are Artificial and Intelligence Hack MY74 from Malaysia. And our project is LAUT AMAN, Human Risk-Based Coastal Connectivity Planning for Fishermen Safety under the Industry Improvement Challenges. So our project starts with one simple idea. The sea is a workplace too. But unlike workplace on land, the people working at the sea may not always have the reliable connectivity when they need it the most. Fishermen may spend many hours working offshore, creating a mobile population that is not fully represented by the conventional residential statistic. On land, connectivity demand is easier to identify because people permanently live there. Offshore, there may be no permanent resident, but fishermen are still actively working and exposed to risk. Therefore, our key principle is residential population does not equal to the human exposure. Next, the problem statement. This creates what we call the offshore connectivity blind spot. As fishermen operate further offshore, mobile connectivity may become weak or unavailable. During severe weather, boat failure, medical emergency, or accident, limited communication can become a serious safety concern. Traditional connectivity planning generally follow populations and demand, but offshore, low residential population does not mean low human risk. And this is the planning gap that LAUT AMAN aims to address. LAUT AMAN has three main objectives. First, identify offshore areas with high fishing activity. Second, analyze where fishing activity overlaps with weak connectivity and maritime risk. And third, prioritize three areas according to the human risk and connectivity interventions need. In short, we prioritize risk, not residential population alone. Proposed data input. To achieve this, our proposed framework integrates three main geospatial data layers. First is human exposure represented by GPS or AIS vessel data, including the vessel movement, fishing frequency, and the time spent offshore. Second is connectivity, using the mobile network coverage, signal availability, and coastal tower relocation. And third is maritime risk, including the weather, sea condition, and historical maritime incident. Together, these three layers provide a more complete picture of offshore safety needs. Solution methodology. So how does LAUT AMAN work? First, we collect and prepare vessel, connectivity, and maritime risk data. We then detect the fishing activity hotspot to understand where fishermen are most active. Next, we analyze connectivity blind spot and integrate maritime risk information. These factors are combined into our human risk priority index. Conceptually, priority risk is based on the human exposure multiplied by the connectivity gap multiplied by the maritime risk. Therefore, higher exposure, weaker connectivity, and greater maritime risk result in a higher priority for the future interventions assessment. Proposed solution. The result is the LAUT AMAN decision support dashboard. Instead of presenting raw geospatial data separately, LAUT AMAN transformed them into the actionable information. The system produces a fishing activity hotspot map, a connectivity blind spot map, a human risk priority map, and a rank list of a priority zone. For example, consider Zone A. If this zone has a high fishing activity, a high connectivity gap, and a high maritime risk, the system classified it as the high priority zone. However, this does not automatically mean that the infrastructure must be built there. Instead, LAUT AMAN tells decision maker, this is where you should investigate first. The identified zone can then proceed to further technical connectivity feasibility assessment. Benefit and expected impact. LAUT AMAN creates value in four areas. For safety, it highlights areas where connectivity gaps may affect emergency communication. For decision making, it transforms multiple datasets into clearer evidence. For resource efficiency, agency and telecommunication provider can focus technical assessment on areas with the greater potential safety value. And for social inclusion, offshore fishing communities become more visible into connectivity planning. Ultimately, better evidence enable the better prioritizations and safer connectivity planning. Limitations and responsible GeoAI. We also recognize the limitations of our approach. Not every small fishing vessel may appear in GPS or AIS data, and coverage map may not perfectly represent actual offshore signal condition. Therefore, priority areas should be validated using the updated data and field evidence where feasible. We also apply responsible GeoAI principle by aggregating vessel movement for privacy and ensuring transparency in our data and risk weighting. Most importantly, GeoAI supports human decision. It does not replace them. Scalability and sustainability. LAUT AMAN is designed to start local and scale regional. We can begin with a selected Malaysian coastal area, expand across the major fishing regions in Malaysia, and eventually adapt to the framework for coastal communities across the nation. Because the framework is reusable and updated, new vessel connectivity and maritime risk data can continuously improve the analysis. This creates a scalable approach without requiring immediate large-scale infrastructure investment. To conclude, LAUT AMAN transforms offshore human activity, connectivity gaps, and maritime risks into actionable priority intelligence, helping the decision maker identify where connectivity intervention should be investigated first. Because connectivity planning should not only ask where do people live, it should also ask where are people at risk. LAUT AMAN, smarter connectivity, safer seas. Thank you.